All right, folks, welcome to the Stat 220 Labs. I'm your lab instructor, Professor McNamara, and you are in one of the R labs. We're going to be using R through a system called RStudio, and we're using a cloud version of RStudio. So I've sent you a link through Canvas with an invitation to join my space on RStudio Cloud. So when you click the link in that Canvas announcement, you'll get taken to a page that looks like this. And if you have a Google or a GitHub account, you can use those to log into RStudio. But I think most people are going to need to click the sign up button and sign up for an account on RStudio Cloud. So put in your email address, make up a password, put in your name, and click sign up. You might get an email confirmation that you have to confirm before you are able to finish your registration. And then you'll need to come back to this page to log in. So you'll put in your email and password to log in. And when you log in, you'll probably see a page that looks like this. So you might need to go back to that link that I sent you on Canvas again to get back to the invitation. So when you get to that invitation, it'll ask you if you want to join space, which you should do. And then it'll tell you, welcome to the space. You should go to the projects, and you should just see one project called Labs, and then you can click it, the name of the project, to start it. And then it'll take a little while for the project to spin up. RStudio is getting everything ready for you behind the scenes, so we'll just be patient. And when it loads, it will look something like this. And there's going to be three main panes that you can see. And the biggest one is the console. And so the console is where you can enter R commands and they will get run. One thing that R is just like a big calculator. So you could type 2 plus 2 and hit enter, and it'll tell you that's 4. Or you could say, I want the log parentheses 2, and it'll tell you that the log of 2 is 0.693142, whatever. Or you could say, I want the SQRT of 100, and it'll tell you that the square root of 100 is 10. So anything that you could do on a fancy calculator, you can do in R, but you can also do much more because R is a programming language. And we're going to be using RStudio, which is a sort of support environment to help you code in R, and you can have files on your RStudio. So I have already uploaded some files to help you out. So there's a folder called Labs, and I'd encourage you to keep your real labs that you need to turn in this folder. There's a folder called Prelabs, and I'd encourage you to keep your Prelabs in that folder. Then there's this all the R you need file, and this is basically an overview of all the functions that we're going to use in this course. It's kind of like a cheat sheet to remind you of things. And then there's a couple of files. There's a .r history and there's a .r proj file. Those just have to do with your workspace and projects, so you don't need to worry about those. So every week I'm going to go through a pre-lab with you, which is going to tell you everything that you need in order to complete the real lab. Let's just start looking at the pre-lab for this week. So go to the pre-labs folder, and then there's a file stat220 describing data pre-lab. Click that, and it will open up another pane. And we can adjust the sizes of these panes if we want to. This is the pre-lab. This is just some header information where I've put like my name in, and I've said things about a table of contents. And then the real text of this pre-lab starts right around here. So R is like a big calculator. It has functions like log and square root that are built into R. But the thing that makes R really powerful is that anyone can create an R package, which is a bunch of functions that might do a specific thing that are put together with data sets and documentation and then made available on the web so that you can install them. And packages need to be installed in your RStudio. I've done that for you already, but then they need to be run and loaded every time that you want to use them. So we're going to use 3 packages in this course. They're called Lock5Data, which is the data sets that come with our textbook that's written by the 5 locks, lock, and lock. There's also the tidyverse package and then the infer package. And the way that you load a package is you write library, because we're basically like loading in a library of functions. Library, parentheses, and then the name of the package. So in here, I've written library, parentheses, lock5data. And then I have this comment, which is denoted by this £, which is just a little note to you. You need to put the other 2 packages in here. So I'm going to delete that comment, and then I'm going to write the same kind of code again, library, parentheses, and then I'm going to start typing tidyverse. And RStudio is kind of trying to help me. So if I don't want to type out the whole word, I can just hit tab and it'll complete that for me. And then put my cursor outside the closing parenthesis and hit enter. And then I'll type library parentheses infer. So once I've gotten that into this chunk of code, I can click this green play button to get the code to run. So let's look in my console. Some stuff is going to scroll by in the console, and some of it might be red, some of it is other colors. Sometimes it looks like it's error messages, but it's actually just telling you that things are working. So that's good. We've loaded in those packages, and then we have access to them. And then the thing that makes R powerful and useful is that it's designed for working with data. So it gets used by statisticians and data scientists a lot. So we need a data set in order to be able to do some analysis. I have done all the pre-labs with the same example data set. It's called gssclean.csv, and I put it inside this data folder here for you. So you can see it in there. And you could jump back up to the pre-labs folder by clicking on it. So again, I have this code chunk, which starts with tick, 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 curly braces, some stuff, and then it ends with tick, tick, tick. It should be gray, at least on your screen when you're logged in. And I've got a comment in there again. So it says, this is where the data loading code goes. I'm going to delete that out and type some code. And what I'm going to type is GSS, because that's what I'm going to name this data set. And then I'm going to use the assignment arrow. So this is a less than sign and then a dash. And that's going to put the result of some code that I'm writing into a new thing named GSS. And what I'm going to put in there is the result from the function read_CSV, parentheses. And then inside those parentheses, I need quotation marks. And inside the quotation marks, I need to write the file path to that data file. So I could just type it out if I am really good with file paths, but I find that the easiest thing to do is to use tab completion. So if I hit the tab key here, it'll tell me, oh, there's a folder inside here called data. And if you hit tab, then it'll fill in that part of the file path and then show you what's inside that folder. It's just GSS clean. So I can hit tab again and it'll complete that for me. So again, I can get my cursor outside of the parentheses, and I could hit the play button to get it to run that code. And again, this kind of looks like errors, but it's actually just messages. It's telling me the way that it loaded the data in. And then something else appeared in my environment, something called GSS. And it says 2,348 observations of 45 variables. If I click on it here, it'll pop up a kind of spreadsheet-like version of the data so I can preview it by scrolling around. So this is data from the General Social Survey. It's a random sample of American adults. It's run by NORC at the University of Chicago. And they call people and ask them questions about things like, how many children do you have? How old are you? How many years of school did you complete? What about your father, your mother, your spouse? What was your college major? Did you get a diploma, GED, or other? What sex are you? How many brothers and sisters, etc. So they ask a ton of questions. There's lots and lots of variables. And I've just grabbed some of the variables that I thought might be interesting while we're working in this lab. But there's lots more that actually get collected. So let's go back to our R Markdown document and scroll down. There's some explanation about the data set. And then the thing that we're going to do most weeks in this lab is some R programming. So you're going to be needing to write code in order to get the lab done. But for this first lab, most of the questions are just about looking at the data and then writing some sentences. So we've already written basically all the code we're going to need up here. So that's great. But we're going to look at some of the things about the data by clicking buttons in RStudio Cloud. So I'm just going to make this kind of the full window. So I have listed out a bunch of questions here, and we're going to try to answer them. So the first thing is, what are the cases in the data set? And if I go back and look at my data preview here, okay, I've got someone's age, the highest year of school completed. It looks like the observations here are people. So let's see, people. And then how many cases are there? I could just look over here and see it says 2348, and I could say 2,348. I can tell because it says so in my environment. If I wanted to do a little bit of coding, I could do a little bit more. There's this button that says insert, and if you click insert and then R, it'll make a new code chunk. So that's somewhere that you can write some code. And I could write n row, short for number of rows, of GSS. And if I click the play button here, it'll show me that there's 2348. But you don't need to do that for this lab. You can just say that you looked at the environment. The next question is there any missing data and how can you tell? So I'm going to go back to my data set and just kind of scroll around. So just looking at these first few rows, I can see there's some highest year school completed father missing, a lot of highest year school completed spouse missing. Maybe they don't have a spouse, or maybe they didn't want to say anything about that. I've got some missing college major 1. Maybe they didn't go to college. A lot of missing college major 2. That makes sense. Not everyone double majors. So yeah, we've got plenty of missing data, and I can see that because it says NA in my data preview. So yes, many variables have missing values, including highest year school completed spouse and college major 1. And how can I tell? Well, I can tell because I was scrolling around and I saw those NAs. Then it says, what are the variables? And there are lots of variables here. So there are 45 variables, including things like age, sex, highest level of education, number of children, etc. Then it says name some variables that are quantitative and some that are categorical. So let's think the quantitative ones are going to be the ones that look like numbers. So that's going to be things like number of children, age of respondent, highest year of school completed. And then the categorical variables are the ones that don't look like numbers. My preview is getting a little weird, so I'm going to X out of it and just click on it again, see if that helps. Oh yeah, now this is better. So college major 1, that's a categorical variable, diploma, GED, or other, respondent sex, those sorts of things. So let's go back here. Quantitative age, number of children, highest year of school completed, etc., and categorical, college major, sex, diploma, or GED. I spelled quantitative wrong, but I could right-click and it'll do the spell check for me. That's great. Then number 6 asks you to pick out an observation to write about and find some of the characteristics of that observation. So let's go back to our data preview, and maybe I'll look at observation 7. Looks like this person has 6 children. That's a lot. They're 59 years old. They completed 13 years of school, so maybe like 1 year of college. Looks like their dad didn't go to high school or they didn't report it. Their mom completed 6th grade. Nothing for their spouse. Maybe they're not married, or they didn't go to school. No college major. They got their high school diploma. They're female, and they have 7 brothers and sisters. Okay, that's interesting. They had a lot of brothers and sisters, and then they had a lot of kids. Okay, so let's write some of those things out. So the 7th observation is a female, what did we say, 59 years old, with 6 children and 7 brothers and sisters. She completed high school and maybe 1 year of college. So those are some of the characteristics. Then there's some questions about data collection. Is this a random sample? I think I told you, yes, this is a random sample of US adults. And then it asks, is this an experiment or an observational study? And this is an observational study because experimenters did not manipulate anything about the environment. So can we use these data to determine cause and effect relationships? No, because it is not an experiment. And then the last question is just to think of some questions that we could answer using this data set. So this could be anything. I usually like to think about relationships between variables, but you could also just think about an individual variable. So like, how many people have high school diplomas? But maybe I'd like to know, do older people have more children? I'd kind of think yes. What about, is there a relationship between years of school completed and years of school completed by spouse? Probably, and things like that. So in this class, you're going to need to do an individual project with some data of your choosing. You're going to need to think of some questions kind of like this that you could answer with your data set. So the last thing that I'd like to show you is about this document format. So as I've been going here, I've been writing some sentences, I wrote some code, I added some code into some of these chunks that were already in here, and this document is called an R Markdown document. So it's a way that you can mix R code and sentences, but I want a formatted version of this document for your submitted lab. And the way to get that formatted document is to click this knit button. So when you click knit, you're gonna see some things. Ooh, that actually happened really fast. Usually you will see some code kind of scrolling by, which is RStudio processing the document. And then you get this pop-up, which is kind of a preview of what your lab will look like. And when you look at the pop-up, you can see that things are much more nicely formatted. So in my R Markdown document, I had the title, colon, describing data prelab, tidy, and now that's in big, bold letters. And then down here, I had pound sign, setup and packages. Now that's also a bold header. and I had backticks around some code, like where it says library, and now that's kind of formatted like code. And then there are places where I had some code and the code looks nice. And then you can see that R has actually processed the code and then put the output here. And it happened here as well with the nrow data. And it has the output. So when you knit your document, RStudio runs the whole thing. It runs all of the code that's inside that R Markdown document, and then it turns it into this nice HTML file. So what you want to do is look at the pop-up, which is a little preview, and just make sure it looks good, and then X out of the preview. And what you need to submit for the lab is that knitted HTML document. So let's go over to our Files tab here. It's kind of a long file name, but when we started, we only had one file in this folder. It was a .rmd file. But now that we've clicked knit, we have a second document in the Files tab, which has the same file name, but the extension is .html. And if this was a real lab, I would need to click the checkbox next to that HTML file, and then go to the More gear icon and click Export. And clicking Export is going to make the file download onto my computer. So I can click Download, and I'm just going to have it save on my computer. My files show up in my Downloads folder. Yours might go onto your desktop or Documents, wherever your downloads usually go. And then you're going to need to go to Canvas and upload that HTML file for the final lab. I have a separate video which goes through that process really quickly, just as a reminder.